I think there's just one last test that we need to write. I think we need to write a test that runs through our contract from start to finish. So something that attempts to enter a player into the contract and then attempts to pick a winner. And we should verify that the winner receives some amount of money. And we should also verify that the player's array gets completely reset and emptied out. So we're going to write that test inside this video. Let's give it a shot. Back inside of our test file, at the very bottom, we'll add on a new it block. So we'll say that this one has a description of it sends money to the winner and resets the player's array. Don't forget to add on the async keyword over here for our arrow function, like so. All right, and then inside of here, we can start writing the actual test. Before we do, I want to talk about the strategy for this test just a little bit, because this one is going to be a little bit more complicated to write than some of the other tests that we've done so far. The first thing I want to remind you about is that the pick winner function is random in nature. So if we enter in, say, 3, 4, or 5 players into our contract and then call pick winner, we would have to write a lot of code inside of our test to look at the account balance of those 3, 4, or 5 players and figure out exactly which one won the lottery. So rather than writing all that logic, we can take a little bit of a shortcut. We're going to instead only enter in one player to the contract. So we'll always know that that one player will be the winner when we call pick winner. Of course, yes, this kind of doesn't test out the random nature of the contract that well, but it's going to make writing the contract or writing the test much more easy and straightforward. So we're going to only enter in one single player so we don't have to deal with the random nature of who actually wins. All right, so let's give this a shot. Back inside of our it block, we'll first start off by entering in one player to our contract. So we'll say await lottery methods enter.send. And we will enter in, how about accounts at 0. So this is the person who's going to enter into the contract. And we're going to send in some minimum amount of ether. This is the amount of money that they are essentially wagering on the lottery, as we've spoken about several times before. Remember that the value right here needs to be in terms of way. So we're going to use that two-way helper again that is a part of the Web3 library. So we'll say Web3 utils two-way. And this time around, rather than sending in 0.02 ether, let's make our lives a little bit easier. We're just going to send in 2 ether, period. So 2 ether, like so. So this is going to be a little bit easier for us because now we don't have to worry about that like 0.02 that we were dealing with earlier up here. Just send in 2 and that's good enough. And of course, this could just as easily be, say, 1 ether, really whatever we want it to be. Now we have to figure out some way of figuring out exactly who is going to win the contract, or exactly how we're going to figure out the accounts at 0 wins when we call the pick winner function. So I'm thinking that one possible way to approach this would be to retrieve the account balance, or the amount of ether that accounts at 0 controls, both before and after calling the pick winner function. Because that accounts at 0 just sent in 2 ether to the contract. And when we call pick winner, they should essentially just receive that 2 ether right back. So if we get the amount of ether that accounts at 0 controls both before and after calling pick winner, we should see that those two balances are different by 2 ether, almost exactly 2 ether. And I say almost for something that we'll talk about in just a second here. So back inside of our it statement, we will get the initial balance of accounts at 0, or the amount of ether that this account controls. To do so, we'll say const initial balance, balance is await, and then to get the balance of an account, or the amount of ether that it controls, we can call web3.eth.getBalance. This is a function that will return the amount of ether in units of way that a given account controls. This function can be used with either accounts that are owned by people like you and me, which we refer to as external accounts. It can be also used to retrieve the balance of contract accounts as well. So essentially, you throw any address you want into this function, and that will return the amount of ether that is assigned to that address. In this case, we want to get the amount of ether that is controlled by accounts at 0. So we'll pass that address in, like so. Now we can attempt to pick a winner inside of our contract. Once we pick the winner, accounts at 0 should basically just receive back the 2 ether that they sent in. So we will pick the winner by writing lottery methods pick winner dot send from accounts at 0, like so. One thing that I want to remind you about at this point is to make sure that you've got the await keyword on all 3 lines that we've written out so far. So these are all asynchronous requests that we are making to the local Ethereum network. So you need to make sure you're using the await keyword on all these. Really easy typo, easy little word to leave out. All right, so now that we're calling pick winner, accounts at 0 should essentially be receiving back the 2 ether that they just sent in. So we sent in the 2 ether, we're now 2 ether less, or we have 2 ether less right here at this point for our initial balance. And when we call pick winner, we receive that money back. So we can now get our final balance, which will be again await web3 eth get balance for accounts at 0. And now we can compare the difference between initial balance and final balance. Now you might be thinking that the difference between these 2 balances right here is going to be exactly 2 ether. However, unfortunately for you and me, it is not. So recall that anytime we send a transaction into the network, we have to pay some amount of money in gas to get that transaction to be processed by the network. So the difference between final balance and initial balance is going to be 2 ether. However, we also just spent some amount of money on gas. So in reality, it's going to be slightly less than 2 ether. The difference between initial balance and final balance right here will be slightly less than 2 ether. Now it's going to be really challenging for us to compute the amount of ether that we just spent on gas. So rather than trying to factor in the exact amount of ether we spent on gas, we can say that, well, final balance and initial balance should be basically have a difference of slightly less than 2 ether. So let me show you the code we're going to write to compare the difference between these 2 things right here, and I think it'll make a little bit of sense. So we'll say const difference is going to be final balance minus initial balance, and then we will assert that the difference here is greater than web3.utils.2way, and we'll do, say, 1.8 ether. All right, so we're taking the difference between the 2, and then we are making sure that that difference is greater than 1.8 ether. So why did I pick 1.8 right here? Like, what's the significance of 1.8? Well, basically the 1.8 is just allowing for some amount of gas cost. That's what this 1.8 is doing right here. It's saying we acknowledge that the difference between these 2 things will be around 2 ether, but it'll be slightly less because we just spent some amount of money on gas. We don't know how much was spent on gas, and we don't really care that much. We just want to make sure that the difference here is somewhere in the realm of close to 2, but slightly less than 2. Now, if you really want to see how much we spent on gas, you can always do a console log of final balance minus initial balance, or essentially the difference, which we have right here on this variable. And the difference between these 2 will be around 2 ether. And then whatever amount different it is from 2 ether, or however much offset it is from 2 ether, will be the amount of money that we spent on gas. Okay, so let's now save this file and try running these tests. So back at the terminal, we'll do npm run test. And of course, wait for the compilation process, which I know we all love to wait for. All right, so there's our tests, and here we go. So here's the difference right here between the initial balance and the final balance. So essentially it's 1.99 ether. And it's not exactly 2 ether because we spent a tiny bit of money on gas. So that's why we did the 1.88. Now, if we wanted to, we could certainly update this amount right here from 1.8 to something like, 1.9 or something like that and be a little bit more precise. But honestly, 1.8 is pretty much good enough to verify that, yeah, we received some amount of money back when we called the pick-winner function. All right, now the last thing I'm going to do is to clean up that console log because we don't really need it inside of here. And then just for stylistic purposes, I'm also going to remove the new lines to just put all those lines of code right next to each other. I think that makes it a little bit more legible. Okay, so I think that's basically it for testing of this contract. Now, if you want to, you could add in one more assertion to this test right here. I think that it would be valuable to assert that the players array gets emptied out after calling pick winner. So if you want to, you could always retrieve the list of players from the contract and assert that it's empty and say, okay, look, contract is totally reset and we're ready to go for the next round. And maybe another assertion you could make would be to assert that the lottery itself has a balance of 0. So in other words, assert that all the money that got entered into this first round of the lottery got sent out when we called the pick winner function. So those are two assertions that you could probably make to make this test a little bit more robust. And I'll leave it up to you to add those in if you want to. All right, so I think that our tests here are looking pretty great. Let's take a break and continue in the